Ladies and gentlemen, this is it. You guys have been asking me to cover more complicated sorting algorithms, and to be honest, I have been kind of shying away from that, seeing as that I didn't feel very confident. But now that I've formally learned some of the more complicated sorting algorithms at the university level, I feel more confident, which is why, of course, you'll be getting this 8-episode series called Sorting Algorithms ++. You're watching episode 1, the introduction. More on this after the break. Hello and welcome to Sorting Algorithms ++. Today's video, the introduction, comes to you in 2 parts. First, some words from me before I actually, start going into the content proper. And second, we're gonna do a very brief recap on the things that we've already covered in Sorting Algorithms Redux. That is, of course, the more basic version of sorting algorithms. So let's jump right into part 1. First of all, I'd like to give a huge shout out to my algorithms professor, Dr. Stephen Halim. Without his guidance over the past semester, I will not be able to, bring you all these algorithms in this series. To be honest, quite a few of these things I didn't understand through self-study. I had to actually go through a formal course to sort of solidify the ideas, which is why, of course, I have to give credit where credit is due. Now, the second and also very important thing that I have to mention here is, essentially, this is a somewhat more advanced version of sorting algorithms. What this means is that my pace might be a little bit faster, which is why, of course, if you are absolutely new to all these ideas, I recommend you start from my previous series, that is Sorting Algorithms Redux. You'll find an annotation link to that series somewhere on screen. Third, an overview of the things we will be covering, in this entire series. Essentially, the show will span 8 episodes. This is the first of them 8. We will actually only be covering 3 sorting algorithms in this series of 8. Yes, you heard me correctly. You see, some of these more efficient sorting algorithms actually rely on a kind of complicated data structure. So in order to explain some of these sorting algorithms to you, I have to actually explain the data structure first. So in fact, the next 3 episodes in this series will cover trees and tree sort. The 2 episodes after that will cover heaps and heap sort. And then we will do Redux sort and wrap up the series. Of course, similar to my previous series, Sorting Algorithms Redux, this video will serve as a contents page, which means, of course, as I add new episodes, all the annotation links will be updated basically along this video, so you can click and go there. Of course, there will be a proper playlist on my channel as well, so you can go there as well if you wish. So enough waffling, let's move on to part 2, where we take a look at why we are even doing this. So here's the deal. You remember that in our previous series, Sorting Algorithms Redux, we've actually covered some efficient algorithms and some not so efficient algorithms. Recall the way that we differentiate, efficiency is via a notation called time complexity using the big O notation. Basically, all the algorithms we've covered actually fall into one of 2 categories, either an O(n) square algorithm or an O(n log n) algorithm. Also recall that I explained the meaning of the notation to you, which I'll very quickly summarize here. An O(n) square algorithm means that in the worst case, the algorithm will look at n items n times, making a grand total of n square comparisons. That means if you have a list of 10 items, 100 comparisons will be made. What this also means is that if you have a list of 100 items, 10,000 comparisons will be made. Conversely, for an n log n algorithm, things are a little bit better. Since we are only looking at n items log n times, essentially we make far fewer comparisons with an n log n algorithm. This is especially significant when n is large. As n gets larger, n squared gets much larger, whereas of course n log n grows slower. What you're seeing on screen right now is a little program that I threw together in Java. Essentially what this does is it profiles some sorting algorithms. Notice what happens when I give it 20,000 items. Now, this means n equals 20,000, which means, of course, n squared is pretty darn huge, whereas n log n is significantly smaller. You can look at the times generated from this profiling process. You'll notice how much quicker the more efficient algorithms are. Oftentimes on modern computers, we might be able to get away with doing things inefficiently, especially if we don't have a lot of data to work with. Unfortunately, in many serious applications, you would expect your program to have to chew through lots of data, which is why, of course, you cannot afford a huge delay. So I hope you can see why there's a need for more efficient sorting algorithms. Now that we've covered this, it's time to wrap up this episode. I'll see you the day after tomorrow. We're gonna jump right in to start talking about trees. If you have any comments, queries or suggestions, feel free to leave a comment in the comment section below. Don't forget to check out the official Twitter account for this channel at twitter.com/0612tv. As always, I appreciate every like, favorite and subscription you give me. Until next time, you're watching 0612TV.